Without further ado, Lou Tucker has long been a cloud computing visionary and practitioner and leader. And so you don't want to listen to me. Let's just get Lou up. So welcome, Lou. And a clicker.
Thank you, Joe. Yeah, I actually think IBM outnumbers me in terms of the number of machines they have downstairs. But it'll be interesting to take a look and see if it's still there. The only problem with the machines I have to mention in terms of the Computer History Museum here, you don't hear the sound of the fans going or the air conditioning or everything else. But maybe we can get them to turn up that at some point. So today I wanted to really talk about where OpenStack is going, and I think it's fundamentally changing the face of service delivery. And I think that it's summarizing actually a lot of the other talks that you've seen today in terms of how it's affecting the enterprise, but also then in networking services and the large telcos as they're changing their models. That's also moving into the video area and media. So industry by industry, we're seeing these disruptions happen. And so I think that when we look at this, it's clear that these waves of innovation are being driven by not only Moore's Law, but because of the internet itself and its reach that it can have, and cloud computing. And therefore, we're seeing disruptions in other related industries now that are using these technologies, such as Uber, disrupting the transportation, the taxi business, Airbnb, disrupting hospitality and how we have hotels. Netflix, how we consume videos. We're not going to the video stores anymore. The Blockbusters aren't there. And Amazon's web services, which is affecting now IT. All these disruptions are being fueled by what we're seeing in the internet and cloud computing, and I think that OpenStack is now playing a key role in that. I mean, it's great to see Joe emceeing this because, as we mentioned, back in 2007, he was talking about how cloud computing was fundamentally changing the economics of IT. And this has a lot to do with an analysis of peak versus valleys and more closely matching a demand curve with the capabilities that are made possible only because of cloud computing. You could dramatically scale up or scale down an application to meet that demand curve. You could burst out to other suppliers of capability according to this. And this fundamentally changed something. And so at that time, the primary argument around cloud computing was that of cost, that we could dramatically reduce the cost of computing. Now we're seeing, however, I think the most dramatic thing we've heard from others is the speed of innovation, the time to market, the reduced expenditure and development times when you develop things on top of a cloud. So it's a new world. And in this new world, we now see that there's more virtual machines than physical hosts. That means that now, instead of having to file IT tickets or wait for somebody to deploy a server, as you know, you can, through self-service, which is a key characteristic of cloud computing, you can provision your own machine. You've got responsibility for that. You can spin it up, you can spin it down, you can pay for only what you need. And that means that you've dramatically changed the whole life cycle of these applications and the speed at which companies can bring new services to market. And so some of the leading, even most conservative of the IT companies, such as Bank of America, is embracing this notion of a software-defined data center. And what they mean by that, they're really looking to get the agility of faster time to market. As banks are now opening up branches inside of shopping malls or grocery stores, they need to be able to deliver these services much more quickly and at much lower cost through automation of their services to begin with. They also want to de-risk their investment. And so they're turning to open source. They're turning to OpenStack because you avoid vendor lock-in. They can get these solutions now across the industry with contributions from all these multiple companies contributing to the same platform, but without being locked into an individual company. And they're also now able to have different consumption models. They can run cloud computing applications in their own data center, or they can subscribe to these services from public cloud providers. All of this is really changing the nature of IT organizations when they're looking at what is the IT delivery mechanism and what does it mean to be delivering the services. As we heard from James Staton and others today, the IT departments still have the same responsibilities, but how they deliver the services is changing, and that's due to cloud computing. In fact, in the data center today, the big change there is that configuration and cabling is becoming code. I mean, Andreessen mentioned, software is eating the world, and I very much like the kind of analogy. Software is moving onward here, changing a lot of our operational procedures because it's easier to express it as code. You can have repeatable operations. It's less, error-prone than trying to change that kind of a wiring patch panel in the back of servers. You want this to become configuration. You want it expressed as code. You can validate that that code works, and you can have repeatable operations time and again. This also means you can start expressing things as policy rather than a manual configuration. Because what does a business want? They want policies. They want to be able to say, no information from this place will leave the bounds of my firewall or my data center. This part of the organization should not have access to the information in this other part. Those are policies that now we can express as code and have enforced in the data center rather than trying to do this through manual configuration by logging into a network switch and making changes. So the number of services now is growing, and that's because a lot of these clouds are also becoming connected. You've probably heard the term microservices. For a long time now, I've been looking actually at, we sort of had it wrong. We were talking about, we had infrastructure as a service, platform as a service, software as a service, and the platform as a service I always thought was a little backwards. It should have been that instead of platform as a service, services become the platform. So now the way applications are being constructed is that you're drawing upon different pieces of open source technology, different services provided by different vendors, out of which you are assembling an application. And as our clouds start to get more and more connected, we'll start to see that become more and more possible where you can draw upon these services and count on them for service delivery. In fact, if we look at the number of the keynotes at the OpenStack summits over the years, we're seeing a lot of different verticals now moving into this area that you would not have expected initially. So we're seeing things actually from Best Buy and PayPal, Rackspace and DreamHost and Bloomberg and Comcast. We're starting to see this sort of across different industries, the adoption of cloud computing, and then the changes that they need in OpenStack to support those. So that we want to look very much like AWS so that it's a familiar environment for application developers. But we're driving things such as e-commerce. And we have new use cases coming in all the time so that there are initiatives within the community about really becoming carrier grade, enterprise ready. These are the kinds of terms that are being used today. At the same time, disruptions are happening in other parts of the IT industry. So in the last couple of years, we've seen a lot of emphasis around software-defined networking. And what this really means, again, is the same notion that we talked about just a minute ago in terms of software now coming into the play here. So instead of having fixed configurations, configurations that are manually configured, we now can use software for that, and we can separate out the control plane, which is the control part of networking, from the data plane. So you can still have data planes that are pushing around bits very quickly. They may even be on standard x86 processors with just a lot of NIC cards, but we've separated that control. Initially, we were thinking about that's what we really need to do, and OpenFlow was a way to do that. Now we're seeing it's got a much larger impact because we're actually talking about, well, what are you doing with the networking? Network function virtualization is one of these terms we've talked about. What are those network functions? Load balancers, firewalls, intrusion detection, security. Those are the functions that we're beginning to now virtualize, and that's another disruption that's happening. And in fact, when you look at a lot of the RFPs that are out there by a lot of the major telecommunications companies, they're all looking at OpenStack to be the platform upon which they do this work. And so Neutron is really gaining an acceptance now. And look at the number of different vendors now that are providing plugins which allow Neutron networking to work on that infrastructure. So this is where software-defined networking now has been intersecting cloud computing, and that's happening in the OpenStack community itself. Another place that we're seeing open source move now is into the area of network controllers. So the Open Daylight project is taking this notion, let's define a network controller which can start to orchestrate a lot of these capabilities and do that in software. And do that in the same way that the OpenStack community has done this by creating a foundation, by working together in the community across multiple vendors. This is the new model for cooperation between competing vendors trying to deliver the best value to the customers in an entirely new area. So this is something that's very interesting in terms of how open daylight now is starting to be used in this area. So in networking, we're seeing that hardware-based networking functional appliances are now being replaced by these virtualized services, network functions virtualization. So whether it's DNS servers, CDNs, DPI, we can go right down the list, and that's creating these requirements of the OpenStack platform. As you know, you expect these carriers to be up all the time, carrier grade. You have to start to move to that kind of capability. And the only way you're actually going to do that is you can try to make these environments as resilient as you can, but you also have to look at it at the service level. And the resiliency starts to move into the services requirement. So if an entire data center goes down, you could switch that service to another one. So orchestration is moving up the stack. As capabilities are becoming more and more software, orchestration, the abstractions, we're computer scientists, we do this all the time. You keep moving up the stack, and that's where you get higher and higher capabilities in terms of larger scale, but you also get more and more resiliency because you can move things around and detect problems as they occur and remediate them. In fact, there's now standards that are emerging in this area. So that we've seen Etsy now publish the standards around what they see as network function virtualization. And we've seen another group called OPNFV, where we're seeing OpenStack and Open Daylight come together as reference implementations for this. There's another area, and this is the next place where I think it's moving. We're hearing crickets in the room. How lovely. That's really nice. Can I get that in my backyard at night? I'm in California. I don't hear crickets. I used to on the East Coast, summer evenings. Anyway, the NAB show, which is National Association of Broadcasters, I was at several months ago or whatever. And it's a great show because you're seeing all this really advanced video capabilities. And these are things that are largely hardware-based appliances because that's what we had to be able to do in order to do transcoding and encoding and moving around video and video switching in real time. But there are like two kinds of vendors there. And I sort of made this reference, I think, in Vancouver, so pardon me for those of you who've heard it before. But there are those vendors that essentially a year and a half ago or 2 years ago had the epiphany. They sort of had, you know, that aha moment where they said, stuff's moving to virtualization. And they started building on top, instead of just the hardware-based appliances, they started moving this to software, to virtualized systems. You had other vendors now that are showing up there with having an oh shit moment. They're looking around going, I've invested in all of this hardware, all of this infrastructure, and now it's all changing to software. So I think we have to decide which side of that equation do we want to be on, and this is creating, I think, a whole set of new opportunities. We all experience this essentially whenever we're talking about a DVR in the cloud. That instead of having a spinning disk in your home, you'd like to have your movie stored up in the cloud. The same way that we're getting a lot of our music now from the cloud, or it's being backed up automatically. What's on my phone is just a replica of what I already have up in the cloud. Those are the kinds of things that become possible with OpenStack and with this kind of cloud-based delivery of applications. There's a series of other trends that are going on at the same time in this industry. The competitive pressures are huge. There's all sorts of industry consolidation we're seeing happening. And again, all of these things are happening, and they're made easier and easier and easier if you start moving to a cloud-based environment. One of the big things that's happening is also this migration to an all-IP infrastructure. We've seen the advantages that so we're moving from older technologies to more modern networking technologies in the data center and, of course, cloud computing. So there's now opportunities to have these kind of virtualized cloud-based services replacing specialized hardware. So instead of having these boxes that did encoding, transcoding, you still may have boxes that have GPUs on there, for example, if you have a compute-intensive task. But you can repurpose that. And the real advantage of when you move into virtualized systems is that you can update them. You can update them on the fly. You can have multiple releases per year, whereas having truck rolls to replace hardened, hardware-based systems is very expensive. So the refresh cycle of these things is going to become much, much faster. And then for all of us who are developers, these become brand new opportunities for us to apply our skills in how these services get built and how they get connected. Because one of the things that's true for all of these video-based and media applications, these are workflow pipelines. do A, do B, do C. You have to do that. A new movie comes out, all of a sudden it has to be transcoded into a zillion different formats and delivered to a thousand different theaters. You want to be able to do that through software-based pipelines. And that's where I think this has the real efficiencies. And this becomes an ideal application for a lot of the microservices we're talking about. Do something very simple, very well, highly scalable, connected to the next one in line. And that next one in line may be in your own data center or somebody else's data center. So you could burst where you need additional capacity. So we're seeing this shift now. So SDI is a serial digital interface. Traditionally, this is what has been used to connect video, cameras, and everything else into other systems, editing systems, playback, and everything else. This is being changed into an IP network. This is now being changed so that you're using a software-based controller to manage these things. Now, what you have to be able to do is be much more deterministic about this, because one of the things about hardware is that it's going to do the same thing over and over, and we have to get that in the software as well. But Moore's law is advanced. We've been having great technology producing by companies like Intel and others so that this now becomes really feasible and very much economically possible. The last area that really has to change, and it's great to see actually this whole movement towards these microservices architecture, is that we need new development models. So we've seen Docker, Kubernetes. We've talked a lot about containers here. And I think the most important part about this, and something that the Docker community recognized, this accelerates application development because it makes making your application into a container you can run it anywhere. If you use a particular software library, you don't have to worry about whether it's on the machine or not. It's in your container. That makes it easier for you to have repeatable systems. You can deploy a system at place A, move it to place B, and it's going to operate the same way. You're not going to be interfering with others. That, I think, is a primary advantage that we have in terms of this. Interestingly enough, so we're seeing now this come into OpenStack. And so there's two projects that I think that you've probably heard people make references to. I just wanted to bring to your attention. One is Magnum, and this is where we're looking to having containers essentially as a service on an OpenStack platform. So you can have individual tenants, as you've heard the sort of supposed war between virtual machines and containers. Each has their place, because virtual machines is where we want to use it in a multi-tenant environment to provide the isolation between the tenants. Within a virtual machine, though, you want to then be able to run containers, and you want a fleet of virtual machines to act as your cluster upon which you can run containers. This allows us to get the benefit of both worlds. And in fact, Magnum also can target then being able to do this on bare metal with Ironic. So here we have now a new development model making it easier for developers to develop their applications in containers and then have a choice about where they want to deploy it. And they don't have to involve a new operations team or anything else. They can basically just deploy it into that environment and know that their application will run as it is expected. So Cole is an interesting project as well, and this is where at Cisco we've been contributing a lot. It's really about the installation of OpenStack services as a set of containers. At a certain point, this becomes, turtles all the way down or recursive views of these worlds. But what we're doing is that we're taking the OpenStack services, Nova, Neutron, Glance, running those as containers. Why? For the same reasons that an application would want to run containers. It makes it easier for upgrade these things. They can be idempotent. We know exactly what's in that container when we deploy it. So all of the advantage of that and the rest of the tool chain that's being developed around containers, we can start to use for the deployment of OpenStack services themselves. So we have a choice. Where do we run these containers in OpenStack? Right now, you can run them on virtual machines, or if you're in case that you're also running Ironic on bare metal, you can run them there as well. So the last point, and sort of in summary to all this, I think that we're seeing then how cloud computing and open source itself is really changing how these services are developed and they're delivered. So we need to start rethinking how these applications are now designed and really looking at them as a composition of these set of simpler services. That's how we get the scalability. That's how we get the acceleration and the software reuse, because somebody else may make a great service you want to be able to just use. So it's sort of SOA revisited. Those of you who have enough history to remember service-oriented architectures, we're looking at this again. How do you discover what services are available? How do you know what their APIs are? How do you know what the contracts are, the SLAs behind that service? We need end-to-end orchestration because these services now are going to cross data center boundaries. So you need to be able to count on these services, and the services at the end of the day are generally for a consumer who doesn't care whether you're going from your house. You may have a virtual machine that is running on your router in your home router or whatever, going through one of your ISPs back to some other place. You need to have end-to-end visibility and orchestration. Last, you need to have resiliency. You have to build this into applications themselves. They have to be able to monitor themselves so that they can stand it up. And continuous deployment is simply a fact of life. We have to get over this, so upgrade becomes really important. How do you update the whole life cycle of the application? And the only way we're going to get through this, I'm coining this, we need continuous learning. Because that's what it is with all of these new technologies coming in. We have to be able to update ourselves and our own knowledge to be able to meet these opportunities. So with that, thank you very much. We'll move on.